Hello dear students, welcome back to our channel Study Shark. I have read you all of mine and doing well in your studies as well. Dear students, today we are going to start our third chapter of chemistry, that is metals and non-metal. This is a very interesting chapter and I am pretty sure that dear student, when you will read this chapter, you will find it very interesting, and definitely there are very good concepts which are going to help you in your further classes. Okay, so let's start with class ninth. So in class 9 you have learned about various elements. You have seen that elements can be classified as metals or non-metals on the basis of their properties. Think of the uses of some metals and non-metals in your day life. What properties do you think while categorizing elements as metals or non-metals? How are these properties related to the uses of these elements? Let's look at some of these properties in detail. Now, dear student, let's come to physical properties. Metals. The easiest way to start grouping the substance is by comparing their physical properties. Let us study this with the help of the following activities. For performing activities 3.1 to 3.6, collect the samples of the following metals: iron, copper, aluminium, magnesium, sodium, lead, zinc, and any other metal that is easily available. So activity 3.1. Take the samples of iron, copper, aluminium and magnesium. Note down the appearance of each sample. Clean the surface of each sample by rubbing them with the sandpaper and note their appearance again. Okay. Now, bache, what you have to do? You have to just collect the samples of these metals, and basically what you have to do, you have to rub them with the sandpaper. So metals in their pure state have shining surface. This property is known as metallic luster. Okay, so metals are lustrous. Lustrous means they are very shiny. Now the second is activity 3.2. Take small pieces of iron, copper, aluminium and magnesium. Try to cut these metals with a sharp knife and note your observations. Hold a piece of sodium metal with a pair of tongues. Caution: always handle sodium metal with care. Dry it by pressing between the folds of the filter paper. Put it on a watch glass and try to cut it with the knife. So what you have to do, basically you have to take the sodium metal. You have to basically try to cut it off. Okay. So now put it in the watch glass and try to cut it with the knife. What do you observe? So you will observe, bachche, that sodium metal is a metal that is easily that is easily we can cut it, isn't it? So you will find that the metals are generally hard. The hardness varies from metal to metal. So basically they are talking about sodium as an exception. Okay. Now the next is activity 3.3. Take pieces of iron, zinc, lead and copper. Place any one metal on the block of iron and strike it for the 4 or 5 times with a hammer. What do you observe? Repeat it with the other metals. Record your change in the shape of these metals. You will find that some metals can be beaten into thin sheet. This property is called malleability. Now, dear students, metals have one property, that they can be beaten into the thin sheet. Thin sheet means they can be converted into thin sheets. Now, what this property is called? This property is called malleability. Metals are highly malleable. Like you must have seen aluminium foil. Aluminium foil is the malleable form of aluminium. When we basically beat aluminium so much that it converts into sheets, and these sheets are used as aluminium foils, which we generally take which are used generally to wrap our food. Okay. So next is record the change in the shape of these metals. Okay, so we have already recorded. Now next is you will find that metals can be beaten into thin sheet. This property is known as malleability. Did you know that the gold and silver are the most malleable metal? Yes, dear student, gold and silver are the most malleable metal because these are the only metals which are highly malleable. They can be beaten into very thin sheets. That's why you must have seen gold and silver are used for making ornaments. Okay. Next is activity 3.4. List the metals whose wires you have seen in daily life. Now see, dear student, metals have one more very interesting property. This property is that metals can be converted into thin wires. Okay, so the ability of metal to be drawn into thin wires is called ductility. So this is a property of metals, that they can be drawn into thin wires. So this property is known as ductility. Okay. So if we talk about the most ductile metal, so that is gold. So you must have seen that gold, gold earrings, gold, basically gold is used for making jewelry. So why it is so? Because gold is very ductile metal. It can be converted into thin wires, and these thin wires only are converted into necklace and all these types of things. Okay. You will be surprised to know that the wire of about 2 kilometer length can be drawn from 1 gram of gold. Because gold is highly ductile, we can convert it into thin wires. Now this is, it is because of their malleability and ductility that metals can be given different shapes according to our needs. Can you name some metals that are used for making cooking vessels? Do you know that why these metals are used for making vessels? Let us know this by the following activity. To find out the answer. Take a aluminium or the copper wire, clamp this wire on the stand, fix a pin to the free end of the wire using wax. Heat the wire with a spirit lamp, candle or burner near the place where it is clamped. What do you observe after some time? Note your observations. Does metal wire melt? So, बच्चे, now the next, what is they are talking about? They are talking about that metals are used for making cooking vessels because metal are very good conductor of heat. So basically, they do not melt very easily. They allow heat to pass through them. But if we talk about the non-metals, so non-metals are the substance which could easily burn, which could easily catch fire, and they can, release toxins. So that's why their metals are used for cooking, because they can transfer heat from them. So because of which, when we cook food in the metal vessels, so the food becomes very hot. So basically, that's why metals are used for cooking. Now the next is, this is a very interesting activity. You will see here that metal are very good conductor of heat, and when we fix the pin there, so you'll see that there is an immediate transfer of heat and pin also become very hot. Okay, now the next is, the above activity shows that metals are good conductor of heat and they have very high melting point. The best conductors of heat are silver and copper. Silver and copper are, why silver and copper are best conductor of heat? Because just as silver and copper are the metals which allow more allow more amount of heat to pass through them, or basically they're the conductors which do not resist with heat. They always allow heat to pass through them. Now next is, do metal also conduct electricity? Let's find. Now what do you mean by electricity, dear student? Electricity means the amount of charge that is flowing through the wire on the particular period on the unit time. Okay. So electricity is a basically flow of electrons in the wire. Okay. Flow of charge. So that the flow of charge constitute current, and then current is what? Current is flowing of charge. Now flowing charge, where the charge is coming from? The electrons. Okay. Now the next is activity 3.6. So set up the electric circuit as shown in figure 3.2. So here figure 3.2 is shown to you. Okay. Place the metal to be tested in the circuit between terminals A and B. So battery have two terminals, as you know very well. One is positive terminal, the another one is negative terminal. Does the bulb glow? What does it indicate? So does the bulb glow? If you will see very carefully, so when you will see tested when the metals are kept, so you must have seen that metals are very good conductor of electricity. So they basically allow heat to pass through them. Okay. So when you will connect these wire endings, so you will see that bulb will glow, because the current is passed through these wires which are made up of metals, and definitely if the current is passed, so it will help in glowing of bulb. You must have seen that the wires that carry the current in your home have a coating of polyvinyl chloride, which is PVC, or rubber like material. Why are electric wires coated with such substance? Because see what is happening, they are carrying large amount of charge through them. They are continuously transferring charge from one place to another. So there is a need to coat them with the rubber material, because if we touch them without any what we say precautions, so we could get the electric shock and these things. So that's why they are coated with rubber like material. So rubber like material act as an insulator, and it prevents means if the accidentally we touch that particular wire, so we will not get current. Okay. What happens when metals strike the hard surface? So what happens when metals strike the hard surface? They produce a sound. So metals are sonorous as well. Okay. So metals that produce a sound on striking hard surface are said to be sonorous. Can you now say why school bells are made up of metal? Exactly, dear students. School bells are made up of metals because what is the use of school bell? Basically, when periods get over, the school bell rings. Now, why the school bell rings? You must have read the mechanism of school bell in your class 8th book. So what does happen? That particular what we call it, something metal ball or something like that, hit the bell again and again. So because of which now the bell is made of metal, so when something is hitting the metal, so basically it is producing sound. So that sound again and again, it tells us that the period is over. So basically the school bells have hard metal surfaces so that they can produce sound. So non-metals, let's come to our next topic, that is non-metals. Now, in the previous classes, you have learned that there are very few non-metals as compared to metals. So, in the previous classes, means in your class 9th, 8th, 7th, 6th, you must have read about this, that non-metals are that there are very few non-metals as compared to metals. Some of the example of non-metal are carbon, sulfur, iodine, oxygen, hydrogen, etc. The non-metal are either solid or glass except bromine, which is liquid. So see, non-metals, all the non-metals are solid in state or in the gaseous state, but the bromine or bromine, whatever you say, is the only non-metal which is liquid in the room temperature. Similarly, in the metal case, there is only a metal, that is mercury, which is liquid in room temperature. Lead and mercury are the poor conductors of heat. The reason behind this, that mercury is liquid at the room temperature, isn't it? And the lead is also having very low melting point, so that's why. Now, do non-metals have physical properties similar to that of metal? Let's find out. Now, these are whatever property you have read about metal, just do the opposite of them. Okay, you will get the properties of non-metal as well. Now, see the activity 3.7. Collect the samples of carbon, coal or graphite, sulfur and iodine. Carry out the activities 3.1 to 3.4 and 3.6 with these non-metals and record your observations. Compile your observations regarding metals and non-metals in table 3.1. So, यहाँ पे we have to basically record. Okay, so now we have collected, and now we have to do these activities again, whichever activities we have done with metals, and we have to just record our observations. So you will notice, bachche, that non-metals are not very hard, they are soft, generally soft. Of course there are some exceptions, we'll read about them. They are not so malleable, they are not ductile, they do not conduct electricity, and they are not good conductor of heat as well. They are, they are not sonorous. Okay, they do not produce as much as sound that metals produce. So just I have done the opposite of the properties that I read in metal case. Okay, now on the basis of the observation, record in the table 3.1, discuss the general physical properties of metals and non-metals in the class. You must have concluded that we cannot group elements according to their physical properties alone. There are many exceptions. For example, all metals except mercury exist as a solid at room temperature. So all metal except mercury. See, mercury is the only metal that basically exists as a liquid at the room temperature. But all other metals like what we call this copper, silver, gold, these all metals exist solid in the room temperature. Now from the activity 3.5, you must have observed that metals have very high melting point. But gallium and caesium are the metals which have very low melting point. These two metals will melt if you keep them on your palm, slightly above the room temperature. Iodine is a non-metal, but it is lustrous. See, what we have read about non-metal, the non-metal are generally not so lustrous, but iodine is a metal that is lustrous also. Then next is carbon is a non-metal that can exist in different forms. See, carbon has different allotropes. You are going to read about allotropes in your upcoming chapter. Okay, so diamond is the allotrope of carbon, and it is the hardest natural substance known, and has a very high melting and boiling point. Very high melting and boiling points means that it cannot melt very easily. Generally, what we have read about non-metal, that non-metal generally have very low melting point. But diamond has an exceptional case here because diamond has very high melting point. Now, graphite is another allotrope of carbon. Now, what we have read about non-metal, that non-metal are generally poor conductors of electricity. But here we are reading that non-metals are also good. There are some exceptions, like graphite is a non-metal which is made up of non-metal, that is carbon, but it is a good conductor of electricity. You are going to read about its structure in chapter number 4, and you are going to understand why it is a conductor of electricity. Okay, now alkali metal. If I talk about alkali metals, what are alkali metals? Lithium, sodium, potassium. Basically, why these are alkali? Because they can be dissolved in water. Are so soft that they can be cut with a knife. Okay, they have low density and low melting point. Low density means their density is very less. Density means mass by volume. Means in the given volume, how much particles are present. What so that particular mass when we compare, so we get density. Okay, now. So these are very soft, they have very low density and low melting points. Elements can be clearly classified as metals and non-metals on the basis of their chemical properties. Now the activity 3.8 comes. Take magnesium ribbon and some sulfur powder, burn magnesium ribbon, collect the ashes from formed and dissolve them in the water. Test the resultant solution with blue and red litmus paper. What is the products formed on the burning magnesium, acidic or basic? Now burn the sulfur powder, place a test tube over the burning sulfur, collect the fume produced, add some water to the above solution test tube and shake. Test this solution with blue and red litmus paper. Is the product formed on the burning sulfur acidic or basic? Can you write equations for such reactions? Of course we can write. See बच्चे, equations I'm writing, so see the equations very carefully. Okay, so okay, see here, if I talk about what we have, magnesium. Okay, magnesium. Now this magnesium, when it will react with oxygen, which is gaseous at room temperature, so we will get MgO, which is magnesium oxide. Please put 2 also, 2 MgO. Okay, now if you'll notice here, when you will dissolve this in water, so you will get basically when you will dissolve this in water, you will check, you will see that the litmus paper or red litmus paper turns blue, because this is metal, and when we dissolve it in water, it forms base, and bases turn red litmus paper to blue. You have already read this in class, in chapter number 2. Okay, now second reaction, that is of sulfur. Sulfur is there, and again it is reacting with oxygen, so we are getting sulfur dioxide. So if you'll see here very carefully, dear students, what is happening? See, when the sulfur is reacting with oxygen forming sulfur dioxide, so basically when we will test the sulfur dioxide after adding water and shaking it and then doing test, so we will find out that this particular sulfur dioxide, when you will bring basically your red or blue litmus paper, you will find that this will change color of blue litmus paper to red. That means that this is acidic in nature. So what we can conclude from these activities? We can conclude from these activities that metals generally, metal oxide generally they are basic, and non-metal oxide are acidic in character. And there are some amphoteric oxide as well, which act as both basic as well and acidic as well. So we'll read about them also. There are many amphoteric oxide like aluminium, zinc, many other also. Okay, we'll read about them also. Now let's come to next part, that what happens when metals are burned in air. So you have seen activity 3.8 that magnesium burns in air with a dazzling white flame. Do all metals react with same manner? Let us check by performing the following activity. The following activity needs the teacher's assistance. It would be better if students wear eye protection. Hold any of the samples taken above with the pair of tongues and try burning over the flame. Repeat the other metal samples. Collect the product if formed. Let the products and the let the product and the let the products and the metal surface cool down. Which metal burn easily? What flame color did you observe when the metal burn? How does the metal surface appear when burning? Arrange the metal on the decreasing order of their reactivity towards the oxygen. Are the products soluble in water? So see, what is the activity? The activity is basically we have to collect the samples. We have to what we have to do, we have to burn them. We have to see whether they burn easily. So when you see this, how the metal surface appear when we burning while burning, so it appears white silver color, right? Okay, now are products soluble in water? So there are some products are there which are soluble in water and some are not. Okay, now see, almost all metals combine with oxygen to form metal oxide. See, almost just all metals combine with oxygen to form metal oxide, which is metal plus oxygen will give you metal oxide. Now the second is, for example, when copper is heated in air, it combines with oxygen to form copper second oxide. Copper second oxide means that copper oxide is formed while taking the valency of copper as 2. What is valency? Valency, the combining capacity of an element. Okay, so copper has variable valencies. So basically, when we are taking copper valency as 2, so that is known as copper second oxide, a black oxide. So 2CO Cu plus O2 will give us 2CuO, which is copper second oxide. Okay. Now the next is similarly aluminium form aluminium oxide. See, aluminium I have taken and oxide I have taken, so it will form aluminium oxide. Now aluminium oxide, how you will form the symbol? You know this very well. That aluminium is taken here with valency 3, oxygen is taken here with valency 2. How valency is taken out? You know very well. The aluminium has the atomic number of कितना होता है बच्चा एल्यूमिनियम का एटॉमिक नंबर? व्हाट इज द एल्यूमिनियम एटॉमिक नंबर? वेट फॉर अ मिनट. हाँ, एल्यूमिनियम एटॉमिक नंबर इज 13. yes, now 13 is the atomic number of this atomic number of aluminium, isn't it? We have different atomic numbers, like we have magnesium also with considering atomic number as set 12. Similarly, we have aluminum which has atomic number 13. Now 13 atomic number means that, see, atomic mass of aluminum is 27. You will do half of it, so you will get basically something like 13.5 or something like this, isn't it? So so considering the atomic number of aluminum as 13, so if we'll do the electronic configuration, so it's 2 comma 8 comma 3. So you'll see that valence electrons are total 3, so that's why its valency is 3. Similarly, बच्चे, oxygen, if you'll see oxygen's valency of oxygen is, see, oxygen is what? Oxygen has atomic number of 8. Oxygen has atomic number of 8. Now in the electronic configuration of oxygen is what? See, 2 electrons are here and 6 electrons are here. Okay. Now what happens? Again 2 electrons should be filled here, so there are 2 valence. Okay, so that's why the atomic number of valency of oxygen is 2. So when they will combine, they will form Al2O3. Now to balance this equation, what we put 4 in aluminium and we put 3 in oxygen. Why 3 in oxygen? Because when, see, 3 in oxygen we are putting this because here the if you will see here, so you will find that here it is written 2 O2. So in the basically downward side you will see the O is written. So okay, so basically what we have to do now, to make it 3, we cannot multiply it by 1. We have to basically take LCM. So we will multiply O by 3, so it will become 3 into 2 6. Now Al2O3, now O is 3 here, so here also we want to make it 6. So what we will do, we will multiply the whole formula by 2. So when we multiply it by 2, so 2 into 3 becomes 6. Now 2 into Al, what is Al? Al is 2. Now if you will notice here, so now Al2 also multiply with 2, so it will become Al4. That means aluminum atoms becomes total 4. Now here also we have to make aluminum atoms 4, so that's why we put here also 4. So basically we are balancing the equation. So the final equation becomes 4Al plus 3O2 becomes 2Al2O3. Okay, recall from chapter 2 how copper oxide reacts with hydrochloric oxide, or hydrochloric acid. Copper oxide, how it reacts. We have learned that metal oxide are basic in nature, isn't it? So you know very well metal oxide are basic in nature, but some metal oxides such as aluminum oxide, zinc oxide show both acidic as well as basic behavior. What do you mean by both acidic as well as basic behavior? That means that they are amphoteric oxide. They show both the behaviors. means they act as a acid also. When the base come, they act as a acid for neutralizing it, and when acid come, they act as a base for neutralizing it. Okay, so such metallic oxide which react with both acid as well as base to produce salt and water are known as amphoteric oxide. Aluminum oxide react with following manner with acid and bases. So we have aluminum oxide, that is Al2O3. It will react with HCl. HCl is what? HCl is the acid. So now this aluminum oxide, when it is coming in contact with acid, so it will act as a base. It will neutralize it. So how it will neutralize it? It will form Al AlCl3, okay, and it will form water. Now what will happen? We have to balance it. So we will balance the equation. So basically the product will form like this. You know very well, salt and water is formed whenever neutralization reaction happens. Then the second is Al2O3 plus 2 NaOH. Now Al2O3 plus 2 NaOH will give you what? Now here the NaOH is a base. So this amphoteric oxide, which is aluminum oxide, will act as a acid. So it will form what? It will form, first of all there will be the salt which would be formed sodium zincate, that is Na. So sodium aluminate, sodium zincate I am saying, sodium aluminate, that is NaAlO2. Okay, and your water would be formed. Okay, then you have to just balance the whole equation. Next is most metal oxide are insoluble in water, but some of these dissolve in water to form alkalis. Okay, so most of the metal oxide are insoluble in water. See, most of the metal oxide are insoluble in water. Some of these can dissolve, which we call alkalis. Alkalis are the base that can be dissolved in water. Now, sodium oxide and potassium oxide dissolve in water to produce alkalis as follows. So sodium oxide and potassium oxide dissolve in water. Dissolve in water, that means they are alkalis. So sodium oxide, that is Na2O, will react with water, that is H2O, to give us NaOH. Okay, 2 NaOH. Similarly, potassium oxide, that is K2O plus H2O, will give us 2 KOH, that is potassium hydroxide. Now here it is written, we have observed in activity 3.9 that all metal do not react with oxygen at the same rate. Okay, all metal do not react with oxygen at the same rate. Okay, now same rate means they do not react very nicely. Means ऐसा नहीं है कि they will react in room temperature or something like in the cold water. Every metal I am talking about. Some will react. See, every metal requires its own condition. Some react even in cold water. Some react slightly above the temperature of cold water, or some react when the water is boiling basically. So there are different conditions. Okay. So different metals show different reactivities towards oxygen. Metals such as potassium, sodium react so vigorously that they catch fire if kept in copper. Okay, so they catch fire. Obviously, when you cut the sodium, also you'll see that your sodium is catching fire, because sodium is very reacting metal. It reacts with oxygen immediately and it forms something white. That's why sodium and potassium are the metals which are kept in the kerosene, if you would have seen in the laboratories. Okay, hence to protect them and to prevent accidental fire, they are immersed in the kerosene oil. Many times this question comes in the board exam, that why sodium and potassium should kept in the kerosene oil. The reason behind is that they can cause accidental fires. So in order to prevent these fires, they are kept in the kerosene oil. Always better write answer up to the mark. Don't write unnecessary, because if you write unnecessary, you will definitely regret, because unnecessary explanation teacher cuts marks. Okay. Now next is at ordinary temperature, the surface of metals such as magnesium, aluminum, zinc, lead are covered with a thin layer of oxide. You must have seen that magnesium, the thin layer of oxide is there, that is magnesium oxide, white color. So first, before burning the magnesium, we have to remove that from the sandpaper, isn't it? So these always also basically these metals also react with oxygen slowly. Okay, the protective oxide layer prevents metal from further oxidation. Iron does not burn on the heating, but iron fillings. No, sorry, it is not called fillings, it is called filings. Okay, filling means when you are filling something. Filings is something which is good, which is the correct pronunciation. Okay, so iron fillings, you have to say iron fillings, always you have to say iron filings. Okay. So, but iron filings burn vigorously when sprinkled in a flame of burner. So, why this happened, dear student? We'll read about it. Okay. Copper does not burn, but hot metal coated with black colored layer of copper oxide, but the hot metal is coated with black colored layer of copper oxide. Silver and gold do not react with oxygen even at the high temperature, because these are the metal which require so much of heat, so they do not react with oxygen even when they are given the very high temperature. So anodizing is a process of forming a thick layer of aluminum. Aluminum develops thin oxide layer when exposed to air. Now aluminum oxide coat makes it resistant to further corrosion, because what happens once the coat is formed, now this coat will help aluminum to prevent more or the further corrosion. So the resistance can be improved further by making the oxide layer thicker and thicker. So during anodizing, the clean aluminum article is made in anode and is electrolyzed with the sulfuric acid. Okay, sulfuric acid is electrolyzed. So the oxygen gas evolved at the anode react with aluminum to make it a thicker oxide layer, to make a thicker protective oxide layer. Protective oxide layer means oxide layer that can protect the further corrosion. So this oxide layer can be dyed easily to give aluminum articles an corrective, attractive finishing. Okay, or you can say finish. So after performing activity 3.9, you must have observed that sodium is the most reactive of the samples of metal taken here. The reaction of magnesium is less vigorous, implying that it is not as reactive as sodium. But burning in oxygen does not help us to decide the reactivity of zinc, iron, copper, or lead. Let's see some of the more reactions to arrive at the conclusion about the order of reactivities of these metals. Okay. Now we cannot decide by oxygen, because we are seeing that some metals are there which react with oxygen even at the room temperature without giving any burn or something, without giving any external heat. Some metals are there that are reacting with oxygen at the room temperature only, but very slowly, slightly above the room temperature. Some metals are very rigid that they are not reacting even when we are supplying so much amount of heat. So now let's see some other conditions to whom because other condition why we have to see, so that we can conclude the final reactivity series of these metals, isn't it? So what happens when metal react with water? Now this activity needs teachers assistance. Collect the samples of some metals in activity 3.9. Put some small pieces of sample separately in the beakers half filled with cold water. Okay, now, which metal react with cold water? Arrange them in the increasing order of reactivity. So, did metal produce fire on water? Does any metal start floating after some time? Does metal did not react with cold water in the beakers half filled with hot water? Put the metals that did not react with cold water in the beakers half filled with hot water. For the metal that did not react with hot water, arrange apparatus and observe the reaction with steam. Which metal did not react with even with steam? Arrange the metal in the decreasing order of reactivity with metal. Now seriously, metal react with water to produce metal oxide and hydrogen. So do you know very well that when metal react with water, so what it produce? It produce metal oxide and hydrogen. Now metal oxide are soluble in water. Metal oxide soluble in water, and it dissolve in water. Okay, soluble in water, you know this very well, and dissolve in it to further form metal hydroxide. See what happens, first it will form metal oxide, not further when it will dissolve, so it will form metal hydroxide. Okay, so but all metal do not react with water, so all metal do not react with water, this we know very well. So metal plus water will give us metal oxide plus hydrogen. Metal oxide plus water will give us metal hydroxide. Okay, this is clear, I guess. Now the next is metal like potassium, sodium react violently with cold water. The reason behind is that these metals have very high reactivity. In case of sodium or potassium, the reaction is so violent and exothermic that the evolved hydrogen immediately catches fire. Immediately it catches fire. That's why lot of heat energy is involved in this reaction. So sodium, that is potassium, that is 2K plus 2H2O, which is water, will give us 2KOH, which is sodium hydroxide, plus hydrogen gas plus heat energy. Okay. Now let's come to next reaction, that is with sodium metal. So sodium is 2Na plus 2H2O, which is definitely water. It will give us 2NaOH, which is sodium hydroxide, plus hydrogen, which is H2, plus heat energy we will get. Okay, so this is the reaction with sodium. Okay, so what we are getting, we are getting the base, isn't it? So also the heat energy, because the evolved oxygen that is present, that is catching fire immediately, because these metals are very reactive. Now the reaction of calcium with water is less violent, but it is also very violent. We cannot do it, just like, in a casual way. Okay, so calcium plus 2H2O will give us calcium hydroxide plus hydrogen gas, but in this case it will not form, it is not sufficient for hydrogen to catch fire basically. Calcium start floating because the bubbles of hydrogen gas form stick to the surface of metal. So it start floating. So magnesium does not react with cold water, it reacts with hot water to form magnesium hydroxide and hydrogen. It also start floating due to the bubble of hydrogen gas sticking to its surface. Metals like aluminium, iron, zinc do not react with cold or hot water, but they react with the steam to form metal oxide and hydrogen. Like, so aluminum is 2Al plus 3H2O will give us 2 Al2O3 plus we'll get 3H2. Now in this case also hydrogen will not catch fire. Second, we have 3Fe plus 4H2O will give us Fe3O4 and plus 4H2 gas. Okay, now metals such as lead, copper, silver and gold do not react with water at all, even in the steam, even in with cold water or hot water. Okay, now what happens when metal reacts with acid? Now we have seen the reactions with base, oxygen also, with water also. Now let's see the reactions with acid. So you have already learned that metal react with acid to give salt and hydrogen gas, isn't it? So this is understandable that when metal react with acid, it gives us salt and hydrogen gas. Okay, now metal plus dilute acid will give us salt and hydrogen gas. So but do all metals react in the same manner? Let's find out. Okay, so we'll find out, does all metal react in the same manner. Collect all the metal samples except sodium and potassium again. If the samples are tarnished, rub them with clean and sandpaper. Why we are not collecting of sodium and potassium? Because we have already seen that these metals are very reactive. If they're reacting even with oxygen in the air and catching fire, even with water and catching fire, cold water, so if we'll react them with acid, so I don't know what violent action they will cause, because they are very violent metal. They react very violently, so that's why we are not taking them, because we already know that they are very reactive. So if the samples are tarnished means if they have a coating of some some type of rust or something like another layer, so please rub them and clean them with sand water. Caution, do not take sodium and potassium as they react vigorously with cold water. Put the sample separately in the test tube containing soil dilute hydrochloric acid. Suspend thermometers in the test tube so that their bubbles are dipped in the acid. Okay, so we have to suspend the thermometers in the test tube and their bubbles are dipped in the acid. Observe the rate of formation of bubbles carefully. So we have to carefully observe which metal react vigorously with dilute hydrochloric acid and which metal did you record the highest temperature. Arrange the metal in the decreasing order of their reactivity with dilute acids. So now write the equations for the reactions of magnesium, aluminium, zinc and iron with dilute hydrochloric acid. Let me write the reactions. Okay. So here we are going to write the reactions. So see, first of all, we have magnesium reacting with dilute hydrochloric acid. It will give us MgCl2 plus hydrogen gas. Now hydrogen gas will evolve. So this would be the reaction for magnesium. Okay. Here I am putting 2 also. Wait. Okay. Dilute and 2 HCl. So this is the final equation. Now the next is aluminium. So aluminium plus HCl aqueous react to give aluminium chloride plus H2. Okay, now here you are seeing that here 3 is written. So what we'll do, we'll write here, because here the 3 is, we'll write here also 3. Now here 3 is there, so here also we'll write 3, but you will see there that it will become 6. Okay, and so what we'll do, so we'll basically balance this equation. Okay, we'll put here also 2. We'll put here 6. Here we'll put 3, and here we'll put 2. So I think the equation is balanced. Any problem, bacha, you can ask me in the comment section. Now the next is we have to write the reaction with zinc. So see, zinc is here. Zinc is reacting with hydrochloric acid, forming zinc chloride plus hydrogen gas. Okay, so so if you'll notice here, we have to put 2. Okay, now the next reaction we have to write with iron. So I'm taking iron second. Okay, so plus HCl aqueous I'm taking, here I'm taking solid, here I'm taking solid, here I'm taking solid. Okay, solid. So this will give me FeCl2 plus hydrogen gas. So here you will see that you have to put 2 here, and this is aqueous, and see, all the salt are aqueous, bacche, and all these are gaseous. Okay, so here I am writing gas, and for all these salt I am writing here aqueous. Okay, you have to write here only. Okay, so like these balance equation you will write in examination. Okay, so I hope this is clear. You can take the screenshot quickly. Now let's move to dear student next part. Now see, bachche, there is written that hydrogen gas is not evolved when metal reacts with nitric acid. Now what is the problem with nitric acid? Many students ask that, ma'am, why we always take sulfuric acid? Why we always take hydrochloric acid? Is there any problem with nitric acid? So it is because nitric acid is a strong oxidizing agent. Why there is problem with nitric acid? Because nitric acid is acting as a strong oxidizing agent. Strong oxidizing agent means what happens when the hydrogen gas is evolved, it oxidizes quickly, forming water. Okay, so that's why nitric acid we cannot take. Okay, so itself get reduced to any of the nitrogen oxide, like nitrogen dioxide, nitrogen monoxide, or nitrogen oxide basically. But but magnesium, manganese react with very dilute nitric acid to evolve hydrogen gas. So these are the only metal which react with nitric acid to evolve hydrogen gas. Okay, so in this case the nitric acid not able to oxidize hydrogen gas evolve. The reactions happen like this. Okay, see, we have magnesium. It reacts with magnesium. It will react with nitric acid, that is HNO3 aqueous, to form MgNO3 whole twice plus H2, which is a gas evolved, and this is aqueous. Okay, so like this the reaction happens. Now the next is, you must have observed in activity 3.11 that the rate of formation of bubbles was the fastest in the case of magnesium. The reaction was also most exothermic in this case. The reactivity decreased in the following order: Mg, then less Mg is more than aluminium, more than zinc, and more than Fe. In this case, copper, no bubbles were seen and the temperature also remained unchanged. So this shows that copper does not react with dilute hydrochloric acid. Okay. Now the next is, you must have observed. Okay, aqua regia, the Latin name for royal water. So now we are going to learn about royal water. Okay. See, bachche, now we are going to read about aqua regia, that is known as royal water. Now it is freshly prepared mixture of concentrated hydrochloric acid and a concentrated nitric acid in the ratio of 3:1. Means 3 parts of hydrochloric acid and 1 part of nitric acid is added for making the royal water, that is aqua regia. Okay. It can dissolve, so 3:1 means 3/1. 3/1 ke ratio mein bachcha it is mixed. Okay. Now it can dissolve gold even through neither of these acid can do this alone. Okay, neither of this acid can do this alone means neither of these acid, not even the hydrochloric acid and not even nitric acid. Both of them individually they cannot dissolve gold, but when they come together in the ratio of 3:1 they can dissolve gold. Okay. Now the next is aqua regia is a highly corrosive foaming liquid. It is one of the few regiments that is able to dissolve gold and platinum. So they are the one of the following things which can dissolve gold and platinum. How do metals react with solutions of other metal salts? So this is very important. So now let's do this. So activity 3.12. Take a clean wire of copper and an iron nail. Put a copper wire in the solution of iron sulfate and iron nail in the solution of iron sulfate. Take it in the test tube. Okay. So copper wire you have to put in the solution of iron sulfate and iron nail you have to put in the solution of copper sulfate. Okay. Record your observations after 20 minutes. So after 20 minutes you have to record your observations. Okay. So in which test tube do you find that the reaction has occurred? So obviously bachche, when we are taking copper wire in the solution of iron sulfate, so definitely what will happen, the reaction will not take place because obviously the copper reactivity is less than iron, displacement reaction will not take place. But when the iron nail is added to the solution of copper sulfate, so does the reaction will take place? Obviously the reaction will take place because iron has the more reactivity than copper, so it will displace copper and form with the compound with the another iron that copper was making. Okay. So in which test tube did you find that the reaction has taken place in which iron nail is added in the solution of copper sulfate? On what basis can you say that reaction in the activity has taken place? Can you correlate with the observations for activity 3.9, 3.10 and 3.11? Write a balanced chemical equation for the reaction that has taken place. Name the type of reaction. So see, write a balanced equation for the reaction that has taken place. So I am writing the balanced equation, dear student. I request you to please see it. Okay. So very simple reaction it is. Okay. Not very hard. Okay. Come here. So I will show you the reaction. So first, when we are adding copper in FeSO4 solution, so we will get, so there would be no solution take place, same products would be there. Okay, so no solution, no reaction would take place, it would be as it is. But when you will add copper when you will add iron with copper sulfate, so you will get iron sulfate plus Cu metal displaced. Okay bachcha, so this is what this would be your reaction. So in which your iron, you know very well, it is a shiny black metal. Copper sulfate solution ka color, what is the color of copper sulfate solution? Blue, isn't it? Bluish color, isn't it? Copper sulfate solution, blue color. And iron sulfate solution is basically when the color is fading up. Okay, so colors start fading and it would form iron sulfate solution. Iron sulfate solution's color is what? You have read this in your chapter 1. Iron sulfate solution, it is of green color. Yes, it is of green color. Okay bachche, green color. You have read this in your chapter number 1. I think there was one decomposition reaction in which you have read about this. See, okay, so the next is theory part that is given in your book. We'll quickly read it. So reactive metal can displace less reactive metal from their compounds in the solution or the molten form. We have seen in the previous sections that all metals are not equally reactive. So we have seen that all metals are not equally reactive. Some metals are there which are more reactive than the other metals. Okay. So we have seen, we check the reactivity of various metals with oxygen, water and acid. But all metals do not react with these reagents. Okay. So we were able to put all the metal samples we had collected in the decreasing order of their reactivity. Displacement reactions studied in chapter 1 gives better evidence about the reactivity of metals. Okay, so chapter 1 you have read about displacement reaction, in which you read that the metals with higher reactivity displaces the metal which have low reactivity. Okay, so now what is given the next part? Let's read it. Okay. Displacement reaction study in chapter 1 give better evidence about the reactivity of metals. It's a simple and easy. If metal A displaces metal B from its solution, it means that metal A is more reactive than metal B. So metal A plus salt solution of B will give us salt solution of A plus metal B. Now which metal, copper or iron, is more reactive according to your observation in activity 3.12? So according to 3.12. So copper or iron? So we know very well that iron is more reactive than copper, because when iron is added in the copper surface solution, so there is a displacement reaction. But in the previous case, when the copper nail was added in the basically iron sulfate solution, so there was no reaction, because copper had low reactivity than iron. Okay, so there was no reaction. So this is what we have to study. Okay, now let's talk about the reactivity series, one of the very important part of this chapter. So the reactivity series is a list of metals arranged in the order of their decreasing reactivities. Okay, so reactivity series is what? The list of metals. Okay, which are arranged in the order of their decreasing reactivity. Decreasing activities means decreasing reactivities. After performing displacement experiment in activities 1.9 and 3.12, the following series, table 3.2, known as the activity or reactivity series, has been developed. So this has been developed. So let's read this. So first there is potassium, then there is sodium, according to observing all the things. Reaction with oxygen, reaction with water, reaction with acids. Okay, calcium, then we have magnesium, then we have aluminium, then we have zinc, then we have iron, then we have lead, then we have hydrogen, then we have copper, then we have mercury, then we have silver, then we have gold, then we have platinum. Okay, you can learn these. And similarly, there is one more trick that I'll try to suggest you, which my teacher told me. So it is like this: PSC, PSC, MA, ZINTL, okay, NTL. NTL. Okay. So this is a very good trick. Okay, PSC mesental. Okay, mesin. PNT mesin. You can learn like this, and then rest of the metals I think you can remember. Okay. Okay, one more thing. Wait for a while. That's what I was missing. Mesental. Okay, PSC mesental. So this is a trick, short trick that I would like to suggest you. P stands for potassium, sodium, calcium, magnesium, aluminium, zinc. I stands for what? Can you guess what I stand for? Yes, iron, of course. Then we have N. And also present here. So see, after iron, which metal come? Do you remember this? Yes. So dear student, this is not in your course, but you can definitely research about it. And I think most of the people know this thing which I am telling you. Okay. So please research about N. I think all of you know what is the N present here. Okay. And then T is basically tin, and L is lead. Then after lead, hydrogen comes, then copper comes, then mercury comes, then silver comes, then golden comes, then platinum comes. You can remember these also. Okay, so this was the short trick that I want to share with you. So it goes like this: the most reactive, then reactivity decreases, and then there is a least reactive metal. Now there are some question answers that we are going to do. Okay. So why is sodium kept immersed in kerosene oil? So see, sodium is kept dissolved in kerosene oil because what happens, sodium and potassium are the elements which are very reactive. So in order to prevent the accidental fires that can occur if sodium and potassium are left outside, because they are very reactive, they react with oxygen even when there is no supply of heat, when there is a room temperature. So that's why in order to prevent such types of accidental fires, necessary to keep them in kerosene oil. Next is write the equations for the following reactions. Iron with steam. So iron with steam, how you will write? See, reactions writing in chemistry is the most easiest part, I feel. Okay. So H2O. Okay, it's not in liquid temperature, it's gaseous because it's talking about heat. Next is it will form if I am taking iron with second valency, so it would be just Fu. Okay. Now plus hydrogen. Okay. So like this the reaction will happen. It will form this what we call ferrous oxide. Okay. So I am taking iron with second valency. Okay. Now see here the hydrogen gas is evolved. Now the next is calcium with potassium. Calcium potassium with water. So see calcium is here Ca. When this will react with water, so it will form what? It will form CaO plus hydrogen. Similarly, we have potassium. When potassium will react with water, so it will form potassium oxide plus hydrogen, but hydrogen will immediately catch fire, so there would be release of heat energy as well. I hope this is understandable. Okay, dear students. So now the next question is samples of four metals A, B, and C and D were taken and added to the following solution one by one. The result obtained have been tabulated as following. So metal A, iron sulfate, iron second sulfate when we are taking, so there is no reaction. And so copper second sulfate when we are taking, there is a displacement reaction. Okay, so this zinc sulfate it is not given to us, and silver nitrate it is not given to us. So सबसे पहले dear student, we know very well that this metal A is not giving any reaction with iron sulfate. That means the reactivity of this particular metal A is less than iron sulfate. Copper sulfate it is giving a displacement reaction. That means the reactivity is more than copper. If you remember the reactivity series, you know first comes sodium, first comes potassium, then sodium, then what comes magnesium, then sorry, First come potassium, then come sodium, then come calcium, then come magnesium, then come aluminium, then come zinc, then come iron, then come this what we call lead, then come hydrogen, then come copper. So now iron is not giving any reaction, but copper it is giving displacement reaction. So definitely the metal would be lead, because lead is the only metal that is lying between these two, iron and copper. Hydrogen is also lying, but hydrogen is a non-metal. So obviously metal is what? Metal A is your lead. So lead will definitely not give any reaction with zinc sulfate, because zinc reactivity is more than lead. And secondly, silver it will give reaction because its reactivity is more than silver. So there would be a displacement reaction with silver nitrate. Now metal B is displacement reaction with iron sulfate. That means more reactive than iron. Copper sulfate, it is not giving any reaction. Copper sulfate blank is given to us. We have to fill it. Zinc sulfate it is not given any reaction. So that means its reactivity is more than iron but less than zinc. So what is the metal? More than iron, but less than zinc. Okay, less than zinc, because in zinc it is not giving any reaction. So obviously the element could be zinc only, because see, zinc would not give any reaction with zinc sulfate because it's zinc only, isn't it? So silver nitrate, yes, it would definitely give displacement reaction. Now the metal C is giving no reaction with iron sulfate. That means reactivity is less than iron sulfate. Iron. Copper sulfate, it is giving no reaction. That means from copper sulfate also reactivity, copper also its reactivity is less than copper. Then from zinc sulfate also it is not giving any reaction. So obviously zinc also its reactivity is less. And in this silver it is giving reaction. That means the metal lie between silver and copper. Okay. So the metal is mercury. Okay. Next is metal D, that is giving no reaction with iron sulfate. That means its reactivity is less than iron. Copper sulfate, it is giving no reaction. That means reactivity is less than copper. Zinc sulfate, it is giving no reaction. That means reactivity is less than zinc. Silver nitrate, it is giving no reaction. That means silver also its reactivity is less. So the element could be gold or it could be platinum. Okay. So now according to us, which is the most reactive metal? That is metal number B. Okay. Then next is what would you observe if B is added to a solution of copper sulfate? Obviously there would be a displacement reaction. Arrange the metal A, B, C, D in the order of decreasing reactivity. Decreasing reactivity means first we have to write most reactive metal, then we have to go till at the last till the very least reactive metal. Okay, so सबसे पहले the most reactive metal is B, then there is A, then there is C, and then there is D. So BACD is the correct answer. Now the next is which gas is produced when the dilute hydrochloric acid is added to the reactive metal. So when dilute hydrochloric acid is added to the reactive metal, so obviously your hydrogen gas is evolved. Write the chemical reaction when iron reacts with dilute H2SO4. H2SO4 is a sulfuric acid. So when your iron will react with H2SO4, so basically this would be the reaction. Okay. Iron is reacting with H2SO4. It would give you FeSO4 plus hydrogen gas. Okay, this is also in aqueous. So I hope I have written the reaction. Now next is what would you observe when zinc is added to a solution of iron second sulfate? Write the chemical reaction that is taking place. You know obviously that zinc has more reactivity than iron. Isn't it? Isn't it? So the reaction would be displacement reaction definitely. So iron second sulfate is there. Iron second sulfate. So it is reacting with zinc. It will form zinc sulfate plus Fe. Okay, zinc sulfate is in aqueous state and Fe is in solid form. So this is what I will get after reaction. So you have to write balance equation, bachche. Okay. So I hope this is clear. So all the in-text question I have discussed. Now the next topic comes, how do metals and non-metals reacts. So this is very important topic because in this topic we are going to read about ionic bonding. Okay. So yes, dear student, now we are going to read about ionic bonding. Okay. So how do metal and non-metal react? In the above activities, we saw that reaction of metal with number of reagents. Why do metals and so sorry dear student, there was a slight disturbance which occurred because actually I was making video in this room and someone came immediately. So maybe if the disturbance, if you heard any disturbance, so I'm very sorry for that, but let's continue with our topic. Okay, so we were reading about ionic bonding. Okay, so in the above activities you saw that reactions of metal with number of reagents. Why do metal react in this manner? Let's recall what we have learned about the electronic configuration of elements in class 9. We learned that noble gases which have completely filled valence shell. Noble gases are which gases which have completely filled their what we call valence shell. Like if I talk about one of the noble gas, so that is argon. Argon has the atomic number of 18. Electronic configuration become 2 comma 8 comma 8. Because see what happens according to rule, 2 electron would be here, 8 electron would be here, okay, then 8 electron would be here, okay. So according to this rule, the argon satisfied because why, because it has the atomic number 18. If we add all these, so we'll get 18 only. See, 2 plus 8 is what, 10, 8 plus 8 plus, 10 plus 8 is what, 18, isn't it? So it is satisfying basically. So that's why it is a noble gas, because it has not left any single valence electron in its outermost shell. Okay, so every element, whether it is metal, so every element, whether it is very less reactive or very more reactive, it want to become stable in its life. Stable means it want to complete the electrons in its last valence shell. So that's why, dear student, there is a need for this ionic bonding. Okay, how this ionic bonding occurs, we'll see this. Okay, every metal or non-metal, these all want to become stable in their life. I'm not talking about only metal, but I'm also talking about non-metals. For example, if I take chlorine, so if I take the example of chlorine, so chlorine is a non-metal. Now chlorine atomic number is 17. Its electronic configuration becomes 2 comma 8 comma 7. It need one electron to complete its last valence shell. One electron is needed. If one electron would be there, so its electronic configuration would be complete. It will form 2 comma 8 comma 8, which would be 18. Okay, but right now it is 17 because 2 plus 8 is what, 10, and 10 plus 7 is what, 17, isn't it? So that's why chlorine need one electron. Okay, so like what exactly happens and how it happens, we are going to read. So let's do this. Okay, so we therefore explain the reactivity of elements has a tendency to attain a completely filled valence shell. Let's have a look at the electronic configuration of noble gases and some metals and non-metals. Okay, so we have seen table 3.3 that sodium metal atom has one electron in its outermost shell. If it loses one electron from its M shell, and then its L shell now becomes the outermost shell that has the stable octet. Okay, the nucleus of this atom still has 11 proton, but the number of electron has become 10. So there is a net positive charge giving us the sodium cation, which is sodium positive. Okay. On the other hand, chlorine has 7 electrons in its outermost shell, and it requires one more electron to complete its octet. So if sodium and chlorine were to react, the electron lost by sodium could be taken up by chlorine after gaining one electron. The chlorine atom gets a unit negative charge because the nucleus has 17 proton and there are 18 electrons in its K, L and M shell. This gives us chlorine anion, which is Cl negative. So both these elements can give and take relation between them as follow. Okay, so like this that you are seeing here. So sodium and chloride ion being oppositely charged attract each other and held by the strong electrostatic forces of attraction to exist as the sodium chloride, which is NaCl. It should be noted that sodium chloride does not exist as a molecule but aggregates of oppositely charged ions. Okay, let's see the formation of one more ionic compound, magnesium chloride. Now, before I tell you how magnesium chloride is formed, let's first understand about this sodium formation of sodium chloride. Okay. Now, see, it's very simple. See what happens. I am using this NCRT diagram only because otherwise I have to write again and again. Okay. Okay, see this. No, it's okay. What is happening? See very carefully. Now, sodium is your element which has the atomic number 11. Okay, atomic number is 11. Sodium's, I'm not taking black, I'm taking another color. Okay, red. Let's take red. Now sodium is a element which has the atomic number 11, isn't it? Now 11 if the atomic number is 11, how the atomic number means number of electrons and number of protons, isn't it? So number of proton is also 11 and number of electron is also 11. But when it comes to electronic configuration, so see, 2 electrons are in the first cell. In this cell there are 8 electrons. Okay, and in the outermost shell still 1 electron is left. Now because of this 1 electron, the sodium cannot become stable, because what's the condition? That the outermost shell should have 8 electrons. Okay, but it has only 1 electron. So what sodium can do? Sodium have two chances. Either sodium could take 7 electrons from somebody and become a stable atom, because 7 plus 1 would become 8. Or what else sodium can do? Sodium can lose one electron and could become stable. What would be easy for sodium? See, gaining 7 electron is not good, because if sodium will gain 7 electrons, what would happen? The 11 protons would not be able to hold 17 electrons, because see, 11 electrons were already there, 7 more are added, so 17 electrons. Okay, sorry, I mean that 11 electrons are already there. If 7 more are there, so 18 electrons are there and still 11 protons are there. So it's not possible for 11 protons to hold say 18 electrons. So what sodium can do? Sodium has only one chance to lose one electron, because losing one electron will basically require less energy. Instead of taking 7 electrons and fully it becomes 18 electrons, and it's difficult for 11 protons to hold these 18 electrons together. So what happens? This one electron, what happens? Sodium want to lose its one electron. Now let's come to chlorine case. Now chlorine is a element which has atomic number 17. Okay, its electronic configuration becomes 2, 8, 7. Now see, everything is fine, but chlorine needs just one electron more to complete its valence electron, to complete the space. Because the last cell requires 8 electron, but it has 7 only. Now chlorine had two options. Either to lose 7 electron, or instead to gain 1 electron. What do you think would be easy for chlorine? Obviously chlorine could not lose 7 electrons, because if chlorine would lose 7 electrons, so what will happen? It is very difficult for basically your 17 basically it would require so much of energy, and that much of energy chlorine does not have. So what will happen? Chlorine can do only one thing. Chlorine can only gain 1 electron, because it will require less energy and it is gaining just 1 electron. So it is possible for protons also to hold 18 electrons together. So What chlorine will do? Chlorine will gain one electron. And what sodium will do? Sodium will lose one electron. So now these both are partners. One wants one electron and the another wants to lose one electron. So what will happen? These two will come together. Sodium will give its one electron and chlorine will gain that one electron. So like this, they both will become. See, when sodium will lose one electron, so what will happen? Now the number of proton is 11 only, but the number of electron reduces to 10. So that's why what happened? Sodium become positive cation. Cation, why? Because the one electron has gone. Now what in the case of chlorine? Chlorine is gaining one electron. So 17 protons were there, 17 electrons were there. But when chlorine gained one electron, so what happened? Chlorine become negative because 18 electrons are there now and 17 protons are there. So that's why chlorine becomes anion. So these two cation and anion now comes together. They do this ionic bonding. They basically give electron and one gain electron. So like this, they both come together, they both form the bond, and they are then held by strong electrostatic force of attraction because both are opposite ions. Okay, so they both attract each other. So like this, the different ions are formed. And what is your salt? Salt is also ionic compound only. It is formed of ions only. Ionic compound means the compound formed by this only. When one electron, one element wants the electron and the other element want to lose electron. So okay, so I hope you understood how sodium chloride is formed. Okay, so now in exam you will not draw these diagrams. You have to simply do this thing. Okay, what is this? First of all, you will write Na. Na is what? Na plus and negative. Now what is happening basically? See, Na is losing one electron. See, Na initially it is this. Now Na, when Na is positive, Na will become positive only when it will lose one electron. So plus one electron gives us Na. Okay. See, Na positive plus one electron will give us Na. Is it true or not? I hope you are understanding what I mean to say. See, it has electronic configuration 2, 8, 1. It has electronic configuration 2, 8, and this is 1 electron. Now, when we'll give 1 electron to it, its electronic configuration will again become 2, 8, 1. Isn't it? Now, we have another side, chlorine. Now, chlorine plus electron will give us chlorine negative ion. Isn't it? So, see, chlorine has electronic configuration of 2, 8, 7. Plus 1 electron, when we will do it, will have the electron configuration of 2, 8, 8, which is chlorine ion. Now, when you have done this step also, then your next step becomes this. You have to show how electrons are going. So, one electron, one valence electron of sodium you will show here, and here you will show one valence electron of chlorine. You will show the arrow where it is going. And now you will write in bracket Na positive, and here in these bracket Cl. This one valence electron you have to show with another symbol so that to give the indication that this has came from sodium. And rest all you will write just cross, 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 cross. What is cross, cross, cross? These are the electrons. Okay, in the outermost shell. So like this you have to write an examination. And this question comes up, I think so, 4 marks or 3 or like this it comes every year. So you have to do this ionic bonding very nicely. And this is very easy. Okay. So now next is magnesium chloride. Now magnesium chloride also we will do because there is lot of space. So I think this would be easy to do. Okay. So see, magnesium, it is very easy. See what happens. Magnesium is there having the atomic number as 12. So magnesium, 2 electrons are there. Here are 8 electrons. Here are 2 electrons. Okay. So if you will see, magnesium had 2 options. Magnesium is not stable, of course, because last shell need 8 electrons, but it has 2 electrons only. So it needs 6 electrons more, isn't it? So now there are 2 options for magnesium. Either to gain 6 electrons from somewhere, either taking it from the another element or something like that, or to lose 2 electrons. Now when magnesium will gain 6 electrons, so there is the same problem. 12 protons cannot hold 12 protons cannot hold, dear students, 18 electrons. It's not possible for 12 protons to hold 18 electrons. So the gaining the electron is totally the very what we can say, very poor idea. But what magnesium can do, magnesium has only one option, it can lose 2 electrons because it will require very less energy, and it is very 10 electrons are manageable. Okay, 12 protons can hold 10 electrons. So magnesium will do this only. There is the another chlorine which I already told you previously when I was talking about sodium chloride, so I am not repeating it. So what will happen, these two will do again sharing. Now see, magnesium is here having the electronic configuration of 2 comma 8 comma 2, which is 2 plus 8, which is 10, 10 plus 2 is 12. And magnesium here, because magnesium positive, that is cation, cation has 2 comma 8 and 2 electrons plus 2 electrons. Now when it will add plus 2 electrons, it will again become normal magnesium only. Now chlorine is here, electronic configuration of 2 comma 8 8 comma 7 with 1 electron. So it will become chlorine negative, that is 2 comma 8 comma 8, which is chloride ion. Now one chlorine is not enough for this task because 2 electrons are to be removed. So we will take 2 chlorine. So magnesium sitting with its 2 valence electrons, and here 2 chlorine are sitting with their 1 space left. So these valence electron will go there and fill that space. So now we will write in brackets Mg2 plus, and in the bracket we will write Cl. All the we will write the valence electron, and they will there we will put 1 point where we are filling it. Okay, so basically that 1 point we will fill, and this is happening with both the electrons, so we will write twice at the bottom of it. Okay, so this is very simple. I guess you understood what I mean to say. Okay, so now like this in exam it comes of many other elements also with their salt, how the salt is formed. So you have to show similarly in this manner only, everything step by step how it is happening. Okay, and it's very easy to show the ionic bonding. Okay, covalent bond sometimes children feel difficult, but ionic bond is very easy. Okay, so that's it. Now the next is compound formed in this manner by the transfer of electrons from metal to a non-metal are known as ionic compounds or co-electrovalent compounds. So, compounds formed in this manner. This manner means by transferring electrons from metal to non-metal is known as ionic compound or electrovalent compound because they acquire charge. Can you name cation and anion present in MgCl2? Obviously, Mg is the cation and Cl2 is a anion. Now, properties of ionic compound. This is very important. We are going to learn about properties of ionic compound. So, to learn about the properties of ionic compound, let's perform the following activity. What is the activity? Let's see. Activity 3.13. Take samples of sodium chloride, potassium iodide and barium chloride or any other salt from the science laboratory. What is the physical state of these salts? So, you know very well what do you mean by physical state? Physical state of these salt, they are solid. Okay, now take a small amount of sample on a metal spatula or and heat directly on the flame. Repeat with other samples. Okay, now what did you observe? Did the samples impart any color to the flame? Do these compounds melt? Try to dissolve the samples in water, petrol, kerosene. Are they soluble? Okay, so make a circuit as shown in figure 3.8 and insert the electrodes into the solution to one salt. What did you observe? Test into the solution of test the other salt samples too in this manner. What is your interference about the nature of these compounds? Okay, so we'll read about these compounds. First of all, some of the melting point and boiling point of these compound is given, so we'll quickly see them. So NaCl melting point is 1074 and boiling point is 1686. Lithium chloride, if I talk about, so melting point is 887 and boiling point is 600. Calcium chloride, if I talk about, so melting point is 1045 and boiling point is 9900. Calcium oxide, if I talk about the melting point, is 2850 and boiling point is 3120. Magnesium chloride, if I talk about melting point, is 981 and boiling point is 1685. Okay, so I hope you understood this. Now we have, you may have observed that following general properties for ionic compound. What are the general properties of ionic compound? Let's see. So first is physical nature. Physical nature, ionic compounds are solid and somewhat hard because of the strong force of attraction between. Now you must have read in your chapter 1 of class 9 science book, that is matter in our surrounding. You have read that matter which have very high force of attraction, they are solid. Okay, so like this only, because they have very high force of attraction between them, so they are solid. Because if they are free, if the they don't have high force of attraction, though they must be in the form of liquid or gaseous, but they are very closely attached with electrostatic force of attraction, so that's why they are in solid state. Now if I talk about melting and boiling points, so ionic compounds of high melting and boiling point, this is because considerable amount of energy is required to break the strong interionic attraction. Okay, solubility. What is solubility? Co-electrovalent compound are generally soluble in water and insoluble in solvents such as corrosine, petrol, etc. Okay, now conduction of electricity. So conduction of electricity through solution involves movement of charge particle. You know, electricity is moved only when there is movement of charge, when there is a flow of charge. Okay, so the flow of charge. So a solution of an ionic compound in water contains ions. So it contains ions. Okay. So which moves into the opposite electrodes when electricity is passed through it. Okay. In anode and cathode, you know very well. The positive charge will move in cathode. Negative charge will move in anode. Okay. You know this very well. When electricity pass through the solution, ionic compounds in the solid state do not conduct due to their rigid structure, but ionic compound conduct electricity in the molten state. Molten state, why? Because when they are melted form, they can move, isn't it? Now, but ionic compound conduct electricity in molten state. This is because in molten state, since the electrostatic force of attraction between the positively charged ions overcome due to the heat, this does the ions move freely and conduct electricity. Okay, so like this, we have done this part also. Now we'll quickly see some of the questions that is given to us. Write the electron dot structures for sodium, oxygen and magnesium. So electron dot structures you can write very easily for electron dot structures for sodium, oxygen and magnesium. See, if I talk about sodium already your book has given it. Okay, so this sodium, one electron is valence. See, sodium is here, sodium is equal to sodium cation plus one electron. This is sodium dot structure for sodium. For magnesium it is like this, and for oxygen it is again, see, these two space would be empty, so you can just fill them, okay, with dot. So like this is the dot structure you have to draw for sodium, oxygen and magnesium. Like this only exam questions come. Okay, show the formation of Na2O and MgO by transfer of electrons. So let's show this. So first of all we will talk about Na. So Na is what? Equals to Na positive plus 1 electron. And what is oxygen? Oxygen is equal to, see, oxygen plus 2 electron will provide me what? Oxygen, which is negative, 2 negative plus, okay, this much. Now if you'll see there, so what is happening, this we have write. Now what will happen, we will write the dot structure. Okay, so Na is sitting here with its one electron, and we will take like this, two Na would be taken. Okay, and oxygen is here with its two valence space. So when we will take two Na like this, so this is oxygen, like this. So now you will write Na dot 2. Yes. So this would be your answer. In the similar manner, you have to do this with MgO as well. Okay, MgO also I am showing you because I think you people want me to show this. So first take the screenshot of this one and then I am showing you the next one. Okay. So if I talk about MgO, so see, Mg Mg is equal to Mg plus 2 plus 2 electrons. Okay, electrons. Now what is oxygen is there, isn't it? So oxygen is basically oxygen plus 2 negative. We'll get oxygen negative. Okay, now next is this. See, now we have magnesium here, 2 magnesium. I'm showing you the dot structures. Sorry, we don't need 2, 1 is enough, like this. And we have oxygen here. Okay, now it would become Mg. Okay, now it would become Mg, Mg, this, and like this your answer is written in examination. Okay, so I hope you understood, dear student, how we have to write. So like this only you have to show in examination also. And if you have more time, you can just draw the electronic configuration also. Okay, so now the next is, what are the ions present in these compounds? So what are the ions present in these compounds? So see, in sodium cation, sodium is a cation which is sodium plus 1 charge. Oxygen is basically O2 negative, and Mg is again positive 2. Okay, 2 positive charge. Okay, now what are the next is, why do ionic compound have high melting point? Because ionic compound have very high electrostatic force of attraction between them, because of which they attract each other so much. And when they attract each other so much, so eventually they have very high melting point. It is very difficult to break the electrostatic force between them, which is due to strong attraction of oppositely charged ions. Okay, so I hope this is understood. Now we have our last topic, that is occurrence of metal, and then we have to just do two small topics, that are rancidity and corrosion, that we will cover. Sorry, rancidity we don't have, isn't it? We have only corrosion, so we will cover corrosion also. So now we'll start our next topic, that is occurrence of metal. Okay, so dear student, if I talk about occurrence of metal, so earth crust is a major source of metals. Seawater also contains some soluble salts such as sodium chloride, magnesium chloride, etc. The elements or compound which occur naturally in the earth crust are known as minerals. So at some places minerals contain a very high percentage of particular metal, and the metal can be profitably extracted from it. These minerals are called ores. Okay, so dear student, you know very well that earth crust is the major source of metal. All the metals are found in earth crust. But what it is talking, it is talking that basically the elements or compound, it is talking about that basically the elements or compound which occur naturally in the earth crust are known as minerals. So naturally which elements and compound occur, they are known as minerals. At some places minerals contain a high percentage of particular metals. So at some places minerals contain high percentage of metals, and the metals can be profitably extracted from it. Okay, so these special type of minerals are known as ores. Now see, extraction of metal, if I come in this topic, so you have already learned about the reactivity series of metal. Having this knowledge, you can easily understand how metal is extracted from ore. Some metals are found in earth crust in the free state. Now there are some metals, dear student, there is a category of metal which are found in the free state. Okay, some are found in the form of either compounds. Okay, form of their compound. Okay, some are found in the form of their compounds. The metal at the bottom of the activity series are the least reactive. Metal at the bottom of the reactivity series, they are least reactive. They are often found in the free state. Okay, now, for example, gold, silver, platinum, copper are found in free state. Copper and silver are also found in combined state as the sulfide or oxide ores. So, the metal at the top of the activity series, that is calcium, potassium, like this magnesium, aluminium, they are so reactive that they can never be found in the free elements as a free element. So, these metals, the metal in the middle of the activity series like zinc, iron, lead, etc., are moderately reactive. They are found in the earth's crust mainly as oxides, sulfides, or carbonates. You will find that the ores of many metals are oxide. Okay, ores of many metals means ores are the types of minerals. Okay, they are oxides. Okay, ores of many metals are basically mainly oxides, sulfides, and carbonate. You will find that ores of many metals are oxide. This is because oxygen is very reactive element and is more very abundant in earth. So because of which most of the metals exist as their oxide ores. Now thus on the basis of reactivity we can group metals into the following three categories. What are those three categories? Metals of low reactivity, metals of medium reactivity, metals of high reactivity. Okay, now different technologies can be used to for obtaining the metals falling in each category. Now several steps are involved in the extraction of pure metal from the ore. The summary of these steps are given in figure 3.10. Each step is explained in detail in the following section. Now if I talk about ore, so in concentration of ore there are three sections: metal of high reactivity, then we have metal of medium reactivity, then we have metal of low reactivity. If I talk about metal of high reactivity, so metal of high reactivity, there is a process known as electrolysis of molten ore is there. Okay, now electrolysis means when you are supplying electricity to acquire that pure metal. Okay, pure metal, we have directly we get pure metal. This is in the case of potassium, calcium, sodium, these. Okay, metals of high reactivity. Okay, now metals of medium reactivity, which are zinc, um, iron, lead, or this what we say, copper. So these are found in two sections, either as carbonate ore or either as sulfide ore. So if they are found as carbonate ore, so the process of calcination occurs. Now what happens in the process of calcination? We burn the metal in the absence of oxygen, in the absence of oxygen. And sulfide ore, if they are found as sulfide ore, so what happened? We burn them in the presence of oxygen, that is the roasting process. Now in both of these processes we get the oxide of metal, and then this oxide of metal, there is a simple reduction which happens to remove the oxygen, and we get the metal. Okay, required metal. Now metal of low reactivity, they are found as sulfide ores. We have to just do the process of roasting metal, we directly get the metal, and then we have to just refine it. Now enrichment of ores. Now what do you mean by enrichment? So ores mined from the earth are usually contaminated with large amount of impurities such as soil, sand, etc., called gangue. ठीक है, the impurities must be removed from the ore prior to the extraction of the metal. Okay, the process used for removing the gangue from the ore are based on differences between physical or chemical properties of gangue and ore. Okay, so the pure process used for removing gangue. Gangue is what? Gangue is the waste, the impurities that are present in the metal. So when we remove this from the ore, are based on differences between physical and chemical properties of gangue and ore. Different separation techniques are accordingly employed. So this was a very small section. Now we have extracting metals low in reactivity series. So metals low in activity series are unreactive. The oxide of these metals can be reduced to metal by heating alone. Okay, low in reactivity means like your mercury, your copper, your silver, gold, etc., platinum. Okay, so for example, Chinabar, which is HGS, which is your mercury, mercury sulfide, which is an ore of mercury. Okay, so when it is heated in air, it is first converted into mercuric oxide, which is AgO, and then mercuric oxide is reduced to mercury further heating. Okay, these are the metals of low reactivity. And secondly, it is of sulfide ore. So in sulfide ore, what happens? We burn it in the presence of oxygen. That is the process known as roasting. Then we get the metal oxide, and then metal oxide is reduced to get metal. Okay, so HgO plus 3O2 will give us 2HgO S plus 2S2 SO2, and 2HgO, when we will heat, so we will get 2Ag Hg and plus OG O2. Okay, now this is simple reduction. Okay, now see, next is similarly copper, which is found as Cu2S in nature, can be obtained from its ore just by heating in air, like Cu2S and 3O2. When we will heat it, we will get 2Cu2O and 2SO2. Okay, so this is what copper sulfide when it is combining with oxygen. So we get copper oxide and plus sulfur dioxide. Next, similarly, sulfur copper oxide, when we will add with copper sulfide, so when we heat it, we will get copper plus sulfur dioxide. Okay, so like this also we get the metal. Okay, now extracting the metal or metal in the middle of the activity series. So metal in the middle of the activity series, such as iron, zinc, lead, copper, are moderately reactive. Okay, moderately reactive means they are not as much reactive as these metals, sodium, potassium, etc. These are usually present in sulfide or carbonate in nature. It is easy to obtain metal from its oxide, as the metal sulfide and carbonates must be converted into metal oxides. So the metal or sulfide ores are converted into oxide by heating strongly in the presence of excess air, that is known as roasting, and the carbonate ore are changed into oxide by heating strongly in the limited air. So this process is known as calcination. So the chemical reaction that takes place during the roasting and calcination of zinc ores can be shown as the following. So roasting, 2 ZnS in solid form plus 3O2 in gaseous form. When we will heat it, we will get 2 ZnOs and plus 2SO2, which is sulfur dioxide, which is in gaseous form. Now in calcination process, what happens? Zinc carbonate, that is ZnOCO3, which is in solid form. When we will heat it, we will get ZnO, which is in solid form, plus CO2, which is in gaseous form. Okay, now the next is uh, next, dear student, what you will do next is yes, the metal oxide are then reduced to the corresponding metals by using suitable reducing agents such as carbon. For example, zinc, when zinc oxide is heated with a carbon, it is reduced to metallic zinc. So like this, zinc oxide there, carbon is a reducing agent. Now what will happen? We will just reduce it and we will get zinc plus carbon monoxide. You are already familiar with the process of oxidation and reducing explained in first chapter. Obtaining metals from their compounds is also a reduction process. Besides using carbon coke to reduce metal oxide to metals, sometimes displacement reactions can also be used, because what we keep higher metal which is higher in reactivity with the lower reactivity metal, and we just do their reaction. So we also get like this also the metal. Okay, so higher reactivity metals such as sodium, calcium, aluminum, etc. are used as reducing agent, because they can displace metal of lower reactivity from their compound. For example, when manganese dioxide is heated with aluminium powder, so manganese, aluminum oxide and heat is produced, because obviously you know aluminium is more reactive than manganese. Okay, now can you identify the substance that are getting oxidized and reduced? So obviously you can tell that manganese oxide dioxide is getting reduced, and aluminum is getting oxidized. These distillation reactions are highly exothermic. Lot of heat is released in these reactions. So the amount of heat involved is so large, so that the metal that is obtained after this reaction is obtained in the molten state, in liquid state. So because of this, you must have this seen that when the railway tracks are when railway tracks are broken or they broke, so what happened, basically this displacement reaction is made between this, what we say, iron and these metal which has more reactivity than iron. So what happens when the displacement reaction occurs, so the iron is obtained in the molten state. So like this they quickly join this railway tracks. Okay, so railway tracks displacement reaction are highly exothermic. The amount of heat involved is so large that the metals are produced in the molten state. In fact, the reaction of iron third oxide, that is Fe2O3, with aluminum is used to join railway track and cracked machine part. This reaction is known as Thermit reaction. Okay. Now we have extracting the metal towards top of the reactivity series. Now metals high up the reactivity series are very reactive. They are very reactive. Okay. Now they cannot be obtained. They cannot be obtained from their compound by heating with carbon, because they have more what we say, affinity towards oxygen and or another. So for example, carbon cannot reduce the oxides of sodium, magnesium, calcium or aluminium etc. to the respective metal. This is because the metals have more affinity for oxygen than carbon. These metals are obtained by electrolytic reduction. We pass electricity for the reduction. For example, sodium, magnesium, calcium are obtained by electrolysis of molten chlorides. The metal are deposited at the cathode, which is negatively charged electrode, and whereas the chlorine is liberated at the anode, which is positively charged electrode. The reactions are at the cathode, Na plus 1 electron, negative electron, so we get Na, and 2 Cl minus, we will get Cl2 plus 2 electron minus. Similarly, aluminum is obtained by electrolytic reduction of aluminum oxide. Okay. Now next is refining of metal. So metal produced by various reduction process described above are not very pure. They contain impurities which must be removed to obtain pure metal. Okay, so the most widely used method for refining the impure metal is electrolytic refining, in which in one side, that is your what we say, you matlab ki one side you keep the pure metal and the another side you keep impure metal. Okay, so electrolytic refining, many metals such as copper, zinc and nickel, silver, gold etc are refined by electrolytically. In the process, the impure metal is made the anode, and the impure metal is made the anode, and the thin strip of pure metal is made cathode. Now, in a solution of metal salt is used as electrolyte. The apparatus setup shown in figure 3.12, on passing the current through the electrolyte, the pure metal from the anode dissolve into electrolyte, and equivalent amount of pure metal from the electrode deposited at cathode. So the soluble impurities go down into the solution, whereas the insoluble impurities settle down at the bottom of anode, are known as anode mud. So here it is written, dear students. So pure metal is made cathode and the impure metal is made anode. Okay, so what happened when we pass current? So pure metal from the anode dissolves, basically it dissolves and into electrolyte, and equivalent amount of pure metal from the electrode is deposited in the cathode. So the soluble impurities goes into the solution, whereas the insoluble impurities settle down at the bottom of the anode, and they are known as anode mud. You can see here the reaction is shown. Okay, so electrolytic refining of copper. The electrolyte is a solution of acidified copper. The anode is a impure copper, and the cathode is a strip of pure metal. You can see there, instant on the passing the current, pure copper is deposited on the cathode. So what happened basically? It basically copper go down, and the impurity dissolved in the solution, and the equivalent amount of pure metal deposit at the cathode. So like this the purification of metal happens. Okay, So the impurity dissolve in the bottom that are known as anode mud. Now, metal from the electrolyte is deposited on the cathode. The soluble impurities goes into the solution, whereas insoluble impurities settle down at the bottom of the anode and are known as anode mud. Now, there are some questions. Define the following terms. Mineral, you know very well. The ore from which most amount of metal is extracted, or it contains the large amount of metal. It is known as mineral. The ore, you know very well, present in the earth, which consists of metals. Okay, gang, you know very well, so impurities that are present in the metal. Name two metals which are found in nature of in the free state. Sodium, potassium, these types of metal, sorry, free state, but the sodium, potassium are not found in free state. Copper, gold, silver, these are found in free state. What chemical process used for obtaining metal from its oxide? Obviously, dear student, from its oxide we do reduction. Okay, now corrosion. Let's read about corrosion. So you must have read about the following about corrosion in chapter 1. Silver article become black after some time when exposed to air. This is because it reacts with sulfur in the air to form coating of silver sulfide, that is AgS, that is black in color. Copper reacts with moist carbon dioxide in the air, slowly loses its shine brown surface and gains green coat. This green substance is a basic copper carbonate. Okay, so this is CuCO3 point CuOH whole twice, which is green in color. Okay, now next is iron. When exposed to moist air for a long time, acquires a coating of brown flaky substance called rust, which you called in Hindi junk. So it is FeO3. Okay, it reacts with oxygen basically. Okay, so Fe2O3. And next is, let's find out about the conditions under which iron rust. Okay, so take three test tube placed in clean iron nails each of them, and place clean iron nail each of them. Label test tube 1 A, B, C. Pour some water in test tube A and cork it. Pour boiled distilled water in test tube B and about 1 ml of oil and cork it. The oil will float on the water and prevent the air from dissolving in it. Put some anhydrous calcium chloride in test tube C and cork it. So, anhydrous calcium chloride will absorb the moisture, if any, from the air, leaves these test tube for few days and then observe. You will observe that iron nail rust in the test tube A, and but they do not rust in test tube B and C. The reason you know very well, in test tube B there is a oil which is preventing the air from entering the nail, because you know for rusting it need air also and moisture conditions also. In test tube C it is not even reacting, because in test tube C there is anhydrous calcium chloride, which is definitely, if any moisture is coming from the air, it is absorbing it and it is not allowing that moisture to stay there. Okay, so in the test tube A, the iron nails are exposed to air and water. In test tube B, the nails are exposed to only water, and in nails in test tube C are exposed to dry air. What does this tell us about the conditions under which iron articles rust? Iron articles rust under conditions, बच्चे, it need moisture as well as it need air. Now we let's come to prevention of corrosion. This is the last topic, I guess. So the rusting of iron can be prevented by painting, oiling, greasing, galvanizing, chrome plating, and anodizing, or making alloys. Galvanization is the method of protecting steel and iron from rusting by coating them with the thin layer of zinc. Thin layer of zinc. What do you mean by thin layer of zinc? Bache, basically the thin layer of zinc metal is put in the metal so that we can protect them. What happens? The thin layer of zinc prevent basically them from corrosion. Basically they do not come direct contact with the oxygen present in the atmosphere. So galvanized article protected against rust even when zinc coating is broken. Can you guess the reason about this? Dear student, tell me the reason. This is very simple. I guess you know, because you already know about galvanization. I hope you have read this about in class 8th or ninth. I don't remember, but you have read it. Okay, so please tell me in the comment section. Otherwise, it's very easy. I'll tell you. Okay. Alloying is a very good method of improving the properties of the metal. We can get the desired property by this metal. For example, iron is the most widely used metal. Okay, but it is never used in its pure state. This is because pure iron is a soft and stretches easily when hot. See, dear student, always alloying is useful because alloying helps. See, iron is always mixed with steel or something other metal. Because see, alone iron is not able to make very strong articles. For making strong articles, it's very necessary for alloying process. And alloying process is also necessary for preventing corrosion. So that's why iron is not used as pure form, because pure iron is soft and stretches easily when we basically provide heat. But when we mix it with some amount of carbon, that is 0.05%, it becomes hard and strong. When iron is mixed with nickel and chromium, so iron is mixed with nickel and chromium, we get stainless steel, okay, which is hard and does not rust. Thus if iron is mixed with any other substance, its property change. In fact, the properties of the substance, any metal can be changed if it is mixed with some other substance. The substance added may be metal or a non-metal, okay. An alloy is a homogeneous mixture of, homogeneous means it is uniform mixture of two or more metals or metal or a non-metal. It is prepared by first melting the primary metal and then dissolving other metals in the definite proportion. It is then cooled in the room temperature. Okay, I hope this is understandable. Now the next is pure gold, known as 24 karat gold, is very soft. Never dear student, in the jewels shop 24 karat gold is brought. The reason behind this is that 24 karat gold is very soft, it is very delicate, it can break. So that's why always there is some mixing with silver or copper generally to make it strong. So in India 22 karat gold is basically very popular. And if some jewelers are saying you that we have 24 karat gold, don't believe. Always in gold, bache, always in gold there is mixing. Either it is in small quantity or very large quantity, it does not matter, but there is, because 24 karat gold is very soft, it can't be used for making ornaments, okay. So therefore it is not suitable for making jewelry. It is alloyed with either silver or copper to make it hard. Generally in India 22 karat gold is used for making ornaments. It means that 22 parts of pure gold is alloyed with 2 parts of copper or silver, okay. If one of the metal is mercury, then the alloy is known as amalgam, okay. The electrical conductivity and the melting point of an alloy is less than that of pure metal. For example, brass, an alloy of copper and zinc, that is Cu and Zn. A bronze, the alloy of copper and tin, that is Cu and Sn, and are not good conductors of electricity, whereas copper is used for making electrical circuits. So alloys are not good conductor of electricity. Solder, an alloy of lead and tin, that is lead and Sn, which is आपका tin, has a has a low melting point, and it is used for welding electrical wires together. So you must have seen shoulders in electrician shop, or even some people have it there, that shoulder in their home also. So you must have seen shoulder. So it has low melting point, very less melting point it has, and it is used for welding electrical wires together, okay. Electrical wires together. Now the wonders of ancient metallurgy. So metallurgy is a branch, dear student, of basically science that talks about extraction of metal and how we refine, or all about metals, okay. So the iron pillar near Qutub Minar in Delhi was built more than 1600 years ago by the iron workers of India. They had developed the process which prevented iron from rusting. For this its quality, rust resistant, it has been examined by scientists from all parts of the world. The iron pillar was 8 meter high and weighed 10 tons, which is 6000 kg. So in the ancient years also people knew all these things. Okay, how to prevent rusting and all. Now the question time is there. So let's do the questions. Metallic oxide of zinc, magnesium, and copper were heated with the following metals. So metal 1 is zinc oxide, metal 2 is magnesium oxide, metal 3 is copper oxide. Now, metallic oxide of zinc, calcium, magnesium, and copper were heated with these following metals. So, first zinc oxide is heated with zinc. So, when you will heat with zinc, so what will happen? in which case you will find displacement reaction taking place. So in zinc we will not find any displacement reaction. When zinc oxide is heated with magnesium oxide, definitely there will be a displacement reaction. Copper with you will react it, so we will not have any displacement reaction. Magnesium oxide again बच्चे with zinc, certainly it will not have any displacement reaction because magnesium has more reactivity than zinc. For with magnesium, no. Copper, no, because copper is also less reactivity than magnesium. Copper oxide, if I talk about, so zinc, no reaction. Zinc, yes, definitely zinc reaction would be there, and because zinc has more reactivity than copper. Magnesium, yes, there would be a reaction, and copper, no, because copper is same, isn't it? Now, which metal do not corrode easily? Now, see, the metals which do not corrode easily are basically dear student, you can say that metals which are mixed with other metals, which are alloys. Okay, generally metals which do not corrode easily are generally coated with layer of zinc, or they are painted, or there are many other processes like oiling, greasing. The when greasing, oiling is done in the metals, so basically it prevents corrosion in metals. Okay, now what are alloys? Alloys are the metals which are generally mixed with other metals or non-metals to make very hard substance. Okay, so basically it prevents corrosion as well, and it makes the metal very strong also. So dear student, like this we have completed our today's chapter, and I hope that you have understood all the chapters. Now I'll bring the NCERT exercises of this chapter soon, so stay tuned with Study Shark, and thank you so much for watching.